Good evening, my 11th standard warriors. Welcome to the next lecture, number 5 of fluid mechanics. And it's time we talk about a very interesting property of liquids, and that's called as surface tension. And you will be really amazed to know the different applications that it has. Look at this spider walking on water, as if for it, it's a solid surface. I mean, obviously, you humans cannot do it. But how is it that this insect is able to walk on water? All of this explained in today's class with me, Shreyas, your physics master teacher at Vedantu, and I'm going live. Welcome to JEE Enthuse. I have been teaching for almost a decade now, and yes, you can call me Capto, you can call me Captain, and I'm going to be your navigator, your guide on this channel with regards to physics and every difficulty that you're going to face in this journey towards JEE. So let's crack it together, and do not forget to smash the like button and also hit the subscribe button down there. So what are we going to do in today's class? In today's surface tension and energy class, we are going to talk about this property of fluid which makes it, behave like as if it is under tension. We are also going to talk about what is the force of surface tension, and then we are going to calculate what is the surface energy for any liquid surface. And yes, we're going to do lots and lots of problems between these topics, and we are also going to touch upon bubbles and drops. So stay tuned till the end, because a lot of amazing things to be covered. And yes, do not forget to hit the subscribe if you have not yet subscribed, because then you will miss the important updates. And yep, go smash the like button to show your full support. I'm very good, Sundar, and user, if you do not have time, I'll tell you something. JEE crash course will automatically take care of your regular board studies as well. Once you understand the concept, the time you need to prepare for boards will be very less. So self-study sprint series plus crash is must. Just self-study and sprint may not be enough at times. So because you need the additional push like the mock tests, you need the assignments, you need those lectures. So that's the reason why I always suggest you to study in combo. Hi Shpreet, hi Rakshita, hello Sonal D, hello Varun, welcome. You're the new member to the Vedantu Enthuse family. Welcome aboard my new warrior. Hi Sushila, welcome aboard all my lovely warriors. So let's get going to the session. And yep, I hope you have already hit the subscribe as well as the like button down there. Now, what exactly is this property of surface tension? You might be wondering. See, every surface of a liquid, right? It behaves as if it is a stretched sheet of rubber. You might have all played with balloons. Let's say a balloon bursts. You get the sheet of rubber balloon. How does it behave? It's elastic, right? If you try to stretch it, it comes back. So any surface of liquid, it is like as if it's a rubber sheet which is stretched, and it will always try to contract itself. I'll give you a simple example to visualize. Look at this spider. Okay, just look at this spider. Ideally, what should happen? Ideally, when the spider tries to walk, or any insect tries to walk on the surface of a liquid, the moment it presses its feet, it should sink, right? It should just pierce into the liquid surface and it should sink. Do you guys agree with this statement? Yes, Chandan, you can definitely watch today's session, and make sure if you have missed before surface tension, the topics like hydrodynamics, viscosity, buoyancy, hydrostatic pressure, watch it on this channel. It's already done just few days back. I'm guessing you are busy writing your exams. Make sure you watch it. So we all agree that the legs will sink. But imagine, I tell you, the insect should walk on a stretched sheet of rubber. So what will happen the moment the insect tries to walk? It will create a small depression. It will create a small depression, but the stretching will try to pull back that insect up on the water surface. I'll repeat, the moment you try to walk, or that insect tries to walk, it will apply some force due to its weight on the liquid surface. But like I told you, every liquid surface behaves like a stretched sheet of rubber. So if an insect tries to walk on a rubber sheet, what will happen? There will be a depression. There will be a small, hole, not hole exactly, like a pit kind of thing form, a depression. a surface, concave surface, and because of that it will try to push it back onto the surface. So that effect is only happening because of this special property of fluid, and that is why the insect is able to walk. Now you might be wondering, sir, this is so cool. Can a pandu or can I walk on a liquid surface? What do you think? Well, there's no need to think. You all obviously know you cannot walk on water. So what does that mean if you cannot walk on water? What's wrong with you and what's right with this insect? Why is this insect able to walk and why can't you walk on the surface of water? The answer is the weight. Yep. So the thing is, our human body weight or any normal bodies have very large mass, large weight. So the rubber sheet, the tendency to stretch, the tendency to contract is basically very, very less. The forces by the water are very, very less. They are very teeny meeny. The force to pull it back, when you create kind of a depression, the force to pull it back to its original surface is very less. So it cannot sustain. It cannot sustain the human body weight. That's why you will sink. Correcto. So the forces due to the surface or tension on a liquid are very less. This tendency to pull it back, the tendency of stretching, the tendency to contract is very, very less as compared to normal forces. So these forces are very minuscule. They are in millinewton, sometimes in micronewton. So that's why we do not experience it. But smaller objects, needles, smaller insects will definitely experience it. So coming back, what is surface tension? Surface tension is nothing but a property of a liquid. Okay, it's a property of a liquid to contract, to always minimize its area, as if it was a stretched sheet of rubber. I'll give you a beautiful example. Another beautiful example. Have you used a brush, paint brush, a physical brush in your drawing class? It has bristles, right? These are the bristles of your brush. Have you used it for painting? Yes. Have you used it, everyone? Agree? Disagree? Have you used it? And have you dipped it in water and then you take it out? How does the bristles, these are the bristles, those are the bristles, how does it behave when you take it out? Yes, Sushila, surface tension will change when you change the liquid because it's a property of liquid. So for water, for mercury, for everything else, it is different. So it sticks, right? It sticks. Same thing with your hair. Right now my hair might be all spread out, or your hair might be all spread out. Just dip it in water. What happens? It all sticks. Why is that happening? Think again. Because of surface tension. Don't just say surface tension and then move on. Think why. What's that reason? When they are all spread out, then the water has stuck to all the bristles like this, right? The water, just imagine these are the bristles. This is one bristle, this is another bristle. So the water has stuck here, then here, on both the sides, separately. But what is the property of any liquid surface? To contract, to minimize the surface area. How does it minimize the surface area? By sticking to each other. The moment all these bristles stick together as one single bristle, then what will happen? The water will be only there on this much part. So do you see the inner part of water has now disappeared into the inner layers. So it's no longer exposed. So it's no longer having greater area. It's all like combined together, because of which the net surface area has decreased. Do you guys see that? And that's the reason why it sticks together. Yep, Prudvi, Malu, you can definitely watch it for 2022 batch as well if you want to clear your backlogs, definitely. Got it? So that's the reason why the bristles of a brush stick together when you immerse or dip it in water. Hello, Mansi. Understood? Clear? Now this notion of surface tension is clear in your head? If it's clear, give me a yo, give me a thumbs up in the chat box. Yes, and do not forget to smash the like button in case you have joined in late. Now, I want to know, why does this property come? Why is it that the liquid surface always tries to minimize its area? Why doesn't it try to maximize? Why isn't it just happy with whatever it has got? What is the reason behind it? So let's understand it from molecular perspective. So for that, I will divide any liquid into two kinds of molecules. Any liquid into two kinds of molecules. Okay, I'll give you a simple example. Imagine there are many Pandus, you are all students and you are all gathered for some school function or maybe some event or sports day or some cultural festival. Something is going on in the school. So these are all the kids in the school. Okay, these are all the kids in the school. Okay, now tell me one thing. How many of you like to be number one student? The student who is facing the teacher. How many of you like to be number one student? How many of you like to be number two student? This number two is somewhere here. This is number two. This is number one over here. This is number two. Number two is somewhere at the back. Okay. How many of you like to be number one? How many of you like to be number two? Number one is standing always in the front. Okay. Facing the speaker, the teacher, the principal, whosoever, God knows. And number two, they are somewhere deep inside, hidden in the crowd. How many of you like to be number one, number two? Come on, be honest, okay? I'm not going to judge you. Okay. So, yes, Chandan, the drop of water will always become a sphere to reduce its surface area, but it spreads out on Earth because the surface tension forces are very less and gravitational force is much larger. So, when other forces dominate over surface tension, that effect takes over and that's why water will spread. Otherwise, water would always tend to become a droplet. But due to the effects of gravity and other things, that's why it will spread out. Okay, so my God, everybody is like number one, number one. Okay, if it was me, I would be number two. Because in school, I was like number two. Okay, I never used to like to sit in the front. I used to always like to sit at the back bench or somewhere in the middle and just have a nice time with my friends and yeah, have fun. So that's me and that's you. Okay, interesting. But Arun and Chandan are my friends, looks like it. They will be around me somewhere over here. Thank you, Chandan and Arun, for giving me company. And Sudarshan too. Alright, so now what's the thing out here? Why am I giving you this example? Okay, so there are two categories of molecules. The two categories of molecules are the one on the periphery, the one on the boundary. So they are called as the surface molecules. What are they called? They are called as the surface molecules, like the number ones over here. They are on the boundary. They are on the boundary. Okay. Yes. So, Surya, definitely I'll help you. Just leave a comment after the session ends. I'll definitely reply to your comment. The second type of molecules which are deep inside, below the layer, they are not on the surface, they are below the surface of the fluid. They are called as the bulk molecules. What are they called? Bulk molecules. Fair enough. Now, I have a question for you. When you have molecules of fluid, what is this? This is a molecule or atom of a fluid. Molecule of a fluid. When it makes bonds, what happens? Is energy absorbed or is energy released? When two molecules form bonds here or there, do you think energy is absorbed or energy is released? Think about it quickly. Hello Rashi, welcome aboard. Obviously, when two molecules make bonds, intermolecular bonds, they like to be with each other, so energy is released, right? So, what you will see is the release of energy. Release of energy. And the moment there is energy release, correcto, Avendika, it's not absorbed, it does not absorb energy. If two molecules willingly form a bond, okay, I like you. Oh, you like me? I too like you. Okay, we form a bond. Energy is released. They go to a lower energy state by releasing the energy. So, they acquire lower energy state. So, they acquire lower energy state. They lower their potential energy. Okay, they lower their potential energy, they lower their energy state by releasing the energy and they form a bond. That makes it more stable. So, the stability basically increases. They become more stable, like each other, they release the energy. Okay, now we are in lower energy, now I'm happy. Everything likes to be at lower energy. This pen wants to fall down to lower potential energy. I would definitely love to fall down and lie on my bed. That's lower potential energy. So basically everything likes to lower their potential energy. That means more the bonds, more the release of energy. More the release of energy, that means lower is the final energy state, more is the stability, more is the happiness in those molecules. Agree? That means if you have a molecule, if it can form a bond with another molecule, good. Another molecule, even better. One more molecule, even better. One more molecule, even better. One more, yes, and so many others. But yes, there is a limit till which it can form bonds because of the geometrical space constraints. You cannot have friends all over you, because after a point they are going to block you. They are going to shield you. You can't see the other friends around you. Yep, Chandan, the happy sad rule works. So the point over here is that if you are listening to this story carefully, more the bonds, more the happiness, the better it is for stability, and the lower is the energy, more is the energy released, everybody is happy. And yes, there is a limit, because beyond which you cannot form bonds with thousands of molecules. There is a limit under which you can form bonds around you, be it up, top, down, below, everywhere. Now, out of the surface and the bulk molecules, which molecule do you think is happy? Which molecule do you think is happier than the other? Come on, quickly answer in the chat box. Is it the surface or is it the bulk? Come on, this is very easy. Hi Sundar, welcome aboard. Is it the bulk molecule which is happy, or is it the surface molecule which is happy? Obviously, everybody wants more friends around them, isn't it? Understand the feeling of the molecules, because only when you understand the feeling of the molecules will you understand this chapter of surface tension. Without this, you will be like, what is this? SL? I don't know. Okay, anyways. Great. Bulk molecules will be more happy. So, here is the feeling. A bulk molecule over here. So, if I draw the molecules, these are the molecules. Look at these molecules. Okay, the molecules over here, they are bulk. This is the surface molecules. The surface molecules will be very unhappy. These molecules will start becoming happy because they are inside. They can form bonds with everyone. This molecule will look at these molecules' happiness. Look at them, so happy because they are forming bonds with everyone. They are so happy. These molecules are very, very sad. They will be like, what the hell? I want to go here. I want to be him. I don't want to be him. I don't want to be him. I want to be him or him or him. Isn't it? Isn't it? So, that's why no molecule wants to be on the surface. No molecule wants to be on the surface. If it gets an opportunity, it will try to go down. If it gets an opportunity, it will try to go down. It will always tend to contract. It will always tend to minimize its surface area. Hence, that property of surface tension. Makes sense, my warriors? Everybody agrees with this? Everybody understood? Perfecto? Excellent. So, you'll be like, sir, why can't these molecules go down, sir? Then it will be happy. What if this molecule goes down over here? Well, if this molecule goes down over here, then do you see this is the surface? Now this molecule will be angry. This molecule will be angry at him. Okay, why the hell did you go down here? Now I am exposed. I lost a bond. So, it won't allow it so easily. There is always a battle between the bulk and the surface. Bulk will not let the surface come down. Surface will try to eagerly enter the bulk. And, this battle is won, sometimes not won. So that's how it is. Perfecto. Now, that you understand that, there is a battle between the surface molecules and the bulk molecules. Surface molecules are unhappy. Bulk molecules are happy because more number of intermolecular forces. And that's why the tendency to reduce the surface area. Now, to answer one of your questions quickly, water in space or water drop in space, what is the shape of it? What do you think is the shape of a water drop in space? Water drop in space, it has no other force apart from the intermolecular forces. The only force for it is the surface tension, the intermolecular forces. So that battle has to be won. You want the least number of molecules. You want the least number of molecules on surface. And for a given volume, who has the least surface area? Cone, cylinder, square, cuboid, cube, sphere. What is it? Obviously a sphere. For a given volume, the least area is for a sphere. And hence, the final shape is also spherical in nature. That's the reason for that. For a given volume, the least area is always for a sphere. Any other shape you try to distort it into, the surface area is definitely going to be more. Perfecto. So what happens on ground, on earth? So basically on earth, what happens is, if you look at the drops out here, there are these molecules. They all want to be like this, but gravity is a party pooper. Party pooper, you know what's a party pooper? Basically a person who spoils the party, who spoils the fun, who's, you are all having fun and suddenly you have a guy who's like, hey, come on, we need to go back home. Oh, come on, we need to do this. We should study. We should not party right now. So party pooper, that's what a party pooper is. So what happens is these molecules will now feel to go down because of gravitational force. So they will all tend to go down towards the earth. That is because of gravitational force, and that's why the liquid spreads. The liquid will spread, it will get compressed, it will no longer be spherical because surface tension forces are very, very small. Fair enough. Now, how much is this force? This can be experimentally calculated and it's very easy. So let's look at the force due to the surface tension. So we are now going to talk about the force and then we're going to start with the problems. So pay careful attention over here. This is liquid, okay, and this is the surface of a liquid. So this is the surface of a liquid. The bulk molecules are inside. Now on the surface, experimentally, if you, let's say, draw a hypothetical line somewhere here, okay, I don't know whether you can see that line. I hope that line is visible. Cool. Now, what is the tendency of a liquid surface? To contract. So the surface, basically, what does it try to do? It always tries to contract. It tries to contract from all sides. It tries to contract from all the sides. It's trying to pull it inside. So imagine, just think about it. It's like tension in a string. If you have a string and if you have a point here, this point will be pulled here. There is a pull here, and this point will be pulled over here. This pull is basically called as tension, right? So this is the tension in a string. So if you take a point, you will see on this side, these molecules will be pulled here. These molecules will be pulled here. It's always trying to pull it inwards. That's the tension in a string. It's 1D, but this is 2D element. So if you take this line, not a point, understand, for a 1D element, which is a string, you take a point and you see what is happening on both sides. For a surface, you take a line and you see that the points over here will experience a pull this way. This is the pull experienced by the points on this side of that line. Okay, so that's the line. So there is a pull. There is a pull over here, and the molecules on this side will experience an exactly opposite pull on the other side by Newton's third law, of course. Okay, Newton's third law at work. So there is a pull over here. So that pull can be calculated by experiments, and that pull, I will call it as the force by surface tension. This force by surface tension is directly proportional to the length. It's basically the length, whatever I have shown over here. That length. More the length, more the molecules that will be pulling each other. Less the molecules, less the length, less the force. So that constant of proportionality is S, and that S is called as surface tension of the fluid. This is called as the surface tension. This is called as the surface tension of the fluid. What does it depend on? The only thing that it depends on is the liquid itself. It depends on the liquid itself, and it also depends on impurities, if any, if there are some impurities, and also it depends on the temperature. It also depends on the temperature. If you change the temperature, surface tension also changes. So these are the things that affect the surface tension of a liquid. And if you are wondering what's the unit of surface tension, it's very obvious. This is Newton, that is meter. So the unit of surface tension is Newton per meter. So that's what it is. Okay, Newton per meter. So will the surface tension be given? Yes. If it is not given, you have to find it out by other data. Force will be given, length will be given, find surface tension, or S is given, length is given, find force, or other two are given, find length, so on and so forth. Okay, so unit of surface tension is newtons acting per meter. How big or how small is this? Extremely small. With these values are in decimal values, because like I told you, the force due to surface tension is extremely small and it cannot definitely compete with forces like gravity or your push or your pull. These forces are very teeny meeny, so they are enough to just balance the weights and the masses of teeny meeny insects, not other things. Okay. So why is the force not upward? Why is it sideward? Okay, simple example, Sudarshan. When you pull a liquid surface, or just when you pull a rubber sheet, how is the force? The force is along the surface, right? Because it tends to contract. Contraction force is along the surface. So that's why it's parallel to the surface, not vertically up or down. Because vertically up or down will just compress the fluid. Compressing the fluid? No, that's not the property. A surface tension force does not actually end up compressing. It just tends to contract the surface. Understand that. I hope this is clear. Okay, keep this in mind, very, very important. And surface tension is the force per unit length. Some books have used the symbol T, that is also okay. You can use whatever symbols you want. Some books use the symbol sigma, that is also okay. It's just a matter of the symbol or the alphabet. Okay, so very, very important. So if you take a length, the forces are perpendicular to the length drawn and it acts on either ways by Newton's third law. Okay, very, very important slide. Please memorize this. Please make a mental picture of this. Make sure you understand this. So when you draw a line, the forces act on either sides by Newton's third law and it's proportional to the length, and that's the force of surface tension. So let's do a question. But before that, I want you to pay close attention to this. Look at this liquid surface. Do you see a film over here? And on the film, you have put a thread. Do you see that? Very carefully, you have put a thread. Okay. Now let's forget the thread for now. Just look at this soap film. And I'll ask you a simple question. How many surfaces do you see over here? How many surfaces do you see over here? Okay. Titan Vishnu with only NCERT books studying for CBSE is definitely not enough. It's even difficult to qualify JEE Mains if you just study for CBSE. It is not enough at all. I'm telling you now only. With the crash course subscription available for a month, crash course is not for a month. It's for entire 6-7 months till whatever is the last date, Karnakar Raidi. Okay, it's for till the last date of JEE. Okay, it does not for 1 month. So there is nothing like 1 month for crash course. Yes. Hello Alka. Yep, there are 2 layers. Yes, there are 2 layers. One on the top, the other one is below. It's just that you're not able to see it. It's a ring. The film is attached to the ring. Understand, there are 2 surfaces right over here. Okay, there are 2 surfaces right over here. One surface is this one. This is the first one. And there is one below over here. This is the second surface. Very good. Perfecto. So there are 2 surfaces, one below and one on the top. And there are a lot of molecules in between that. You might think, sir, that film is like the sheet of a paper. A sheet of a paper. Now look at this sheet of the paper. How many surfaces does it have? 1, 2. Isn't it? 1 and 2. In this thickness, do you visualize, or can you visualize that actually there are many molecules in between that? It's just that you're not able to see it through your naked eye. So actually speaking, there are there are lots and lots of molecules in between. Okay, so this might be the molecule on this side, this might be the molecule on this side. These are the molecules inside the bulk. It's just that you do not see it through naked eye, but they are there, and that's why there are two surfaces. Okay. Ramya, Sunday I'm on holiday. Sunday generally there is a leave, so that's why we don't post videos on Sunday. And Saturday I was also on leave anyways. That was my personal leave. That's why I was not available on Saturday. But I'm so glad that you missed me, and here I am on Monday. Don't worry, I'm not going to go anywhere. Here's a question coming up on your screen. A thread is tied between this point and this point by a, it's loose, and it is attached to a circular wire frame, just like before over here. This is a circular wire frame. You have attached a thread from here till here. Okay, so that's what you have done. And what has happened is it's dipped in a soapy solution. The frame is completely covered with the film. Both sides there is film. Now, if you puncture A, so basically you puncture this part, how do you think the thread will behave? Okay, so you connect it from here to here, and then one side you puncture it, other side the film is there. What do you think will happen? Will it become concave towards A? Will it become convex towards A? Will it remain as it is? Or it depends on where are you connecting it. Let's see how many of you can get this. Okay, come on my warriors, figure this out. This is very, very easy. I want you to visualize this and not more than 20-30 seconds, figure this out. Where do you think is the liquid going to go? Where do you think is the thread going to move, or is it not going to move, or does it depend on certain things? Arun saying D, Sudarshan saying B, Chandan saying D, Dakshin saying D. Interestingo. Come on my warriors, think about it. Okay, come on, think. Okay, D, most of you? Well, I feel that most of you are wrong. Okay, the correct answer is actually B. Oh, sorry, A, my bad. Yeah, so why does it become concave towards A? Understand this. The moment you puncture this, okay, so the moment you puncture this particular part A, so there is no film on this side, but this surface is there. There is film right over here. Correct? There is film right over here. This part completely is having that film. What is the surface of a liquid going to do? I just mentioned the property of a liquid surface. The surface always tends to contract. Now, if it tends to contract, it will try to pull everything inwards. It will try to pull, squeeze, reduce the surface area. So what will happen? This will be pulled like this, like this, like this, like this. This will be also pulled, but it's a rigid ring. So that is why the shape of this part cannot change. Do you guys agree? This part, the shape cannot change because it's a part of a rigid ring. But this is a thread. So that thread can definitely change its shape. Obviously, it won't remain like that. It will be pulled inside, and that is the reason why you will see it will become eventually like this. This will be the final shape. Okay, so this shape, can you see? Something like this, because it has been pulled inside, and now the final area, can you see that? The final area is less. So you can see that final area. So the final area has reduced. It has reduced. So that's the reason why it is concave towards A, convex towards B. I hope that makes sense. Got it? So understand the behavior of a liquid. How does it behave? So it always tends to contract. If you had punctured B, then the thread would have gone like this. Then the thread would have gone like that. Okay? If you had punctured B. Okay? Fair enough. Moving on to the next question coming up on your screen. Very good, Chandan, Arun, Dakshin. There is a wire frame. This is, that blue one is a rigid wire frame. C-shaped. One wire here, one wire here, one wire here. You cannot change the shape. You cannot expand, pull, rotate, nothing. There is a rod. The red one is a rod. It can slide on it. You can move it here or move it there. So it's like, you have two rails like this. So think of it like this. You have two rails this way. Okay. And this other one, the red one, you can just slide it on it. Okay, so you have two rails and you can slide it over it like this. Okay, so you can slide over it like this. Okay, and there is a film which is formed over here. Do you see there is a film which is formed over here, the blue one? So the question is, find the force required to keep the removable rod intact. You don't want it to move, you want it to be stationary. So what should be the force? A lot of you are saying, okay, one of you are saying 2SL. Tushar, Vishnu, gravitation is already covered, bacha. Just search for gravitation, Shreyas sir. You will find the videos on YouTube. Gravitation, all the sessions are over already. Kepler's law, satellites, force, potential energy, acceleration due to gravity. It's already done. It's already there in the nurture playlist. Maybe you have missed it by chance. Okay, Sudarshan saying B. Okay, so here is the catch. The catch is that, first of all, understand, escape velocity is there, Tushar. It's there in the potential energy part. You might not see in the heading, probably. It's there in the potential energy discussion. So just check that lecture. It is there. Just search for it. I'm pretty sure you will get it. If you are not able to get it, leave a comment after the video ends. I will ping you the link of that video. Okay, don't worry. Hi Kiran. Hi Basit. So the thing over here is, understand what is the tendency of the liquid to contract from all the sides. So this side will tend to contract like this. This side will tend to contract like this. This side will tend to contract like this. And this rod will tend to get pulled this way. But this light blue section cannot move. It's rigid. So there is no point of this, and these forces. These three sides, the forces are there. It's trying to contract the rod, the C-shaped wireframe. There is no use of it. So there is no point talking about that. What is more important for me is these forces. So this is the pull due to surface tension. Now if this rod has to remain at rest, so for the rod to remain at rest, what is the condition? The pull by surface tension should be equal to the external force. Correct? Now what is the pull by surface tension? Remember, I told you whenever you have a line over the liquid surface, S into the length of that line gives you the force of surface tension. So SL is equal to F external. But there is a catch. And the catch is over here. My dear warriors, I just told you, for a film, how many surfaces are there? One surface here, and there is another surface below, right? This is one on the top, and the second one is below. So SL is there from the top layer, SL is there from the bottom layer, so there are two forces. So that's why 2SL, and hence the answer is option A. Yep. Yes, Darshan, I will be completing all the chapters, bacha. And we have almost done all the chapters. The only chapters remaining after this few classes will be thermodynamics and waves. Even SHM is done, gravitation is done, solid mechanics, elasticity is done, hydrostatics is done, hydromechanics is done, viscosity was done. Now we are on to surface tension already. So yes, if you have missed any of those classes, make sure you watch them. Alright, it's all there, detailed classes, all the chapters. Perfect. So the answer is 2SL. So I'll repeat, the concept over here looks something like this. So if you look at the cross section of the rod, this is the cross section of the rod, and this is the liquid. Okay, this is the liquid. Okay, in between. Okay, this one is the top layer, this one is the bottom layer, and the force due to surface tension, one force is from here, SL, and the other force is from here, SL. So there are two forces, one from the top and one from the bottom. You cannot see it, but it's there. Is that now clear, my warriors? Perfecto. Understood? Is this there in your head? Give me a yo, give me a thumbs up. So there were many students, I'm pretty sure before this, who always used to get confused. Why is it SL? Why is it 2SL? When to use what? So I'm pretty sure now you would have got it and visualized it, how there are two surfaces. Yes, Darshan, I understood your bhavna. I understood what you meant to say. Don't worry. All right. Chalo. Very good, Arun. Very good, Avantika. Very good, Jairoop. And yep, do not forget to smash the like button down there in case you have forgotten, because it means a lot when you smash it. Amazingo. Find the max mass of a cylindrical needle that can be gently placed over the surface of water if the surface tension of water is S. Beautiful. Beautiful. So find the max mass of the cylindrical needle that can be gently placed over the water so that it can be balanced. So I'll give you a hint. Look at this over here. Look at this over here. Ramya will be doing thermo and modern physics in probably the next 2 to 3 weeks max. Okay, max 2 to 3 weeks. Okay, so here we are. Look at this needle, amazing needle, and you can try this out at home. Even now you can try it out. If you have a needle and have a cup of water, fill it with water and place the needle, you will see it will float. You might be wondering, needle is made of steel, and in buoyancy chapter we just studied that steel, because it is denser, it should sink in water. But this needle floats, and it's not because of buoyancy, it's because of surface tension. You might be wondering, again, how can surface tension balance a dense material like steel? The answer is, the needle's mass is negligible, very small, so that's why that small force is enough to balance it. But yes, if you have a big steel block, obviously it's going to sink because the force won't be sufficient. Now here is the thing. When this needle creates a small depression, like a small hollow depression, like a gutter. So if you visualize this diagram, without the needle, there is a small gutter-like shape. I hope you understand what's a gutter, right? Yeah. So Sri Meenakshi, the term 2 preparation starts for 12th standard this week. Already tomorrow at 5 o'clock you have my Pathfinder class. And yes, at 7 o'clock you are going to have your sprint class as well. Okay, so here is the logic, guys. If you realize it, it's amazing. There is a small gutter-like shape formed over here, something like this. Perfect. And in that gutter, you have that needle. But I'm not showing that needle. Just imagine the needle is actually over here. That green one is basically that needle, but I'm not showing it. Okay, that needle is actually there over here, something like that. So if you notice what's going to happen, this is the line on which the force of surface tension is going to act, and also on this line, because this is that surface. Do you see, this is the surface of the fluid, this is also the surface of the fluid, and do you see, if you look at it from here, the force of surface tension will try to pull, so these are the pull due to surface tension. It's there here and here. That means it is there here like this, is there here like this, and it's also there here like this. What do you think each of these force will be? This will be S into the length of the cylinder. This will be also S into the length of the cylinder. These two forces together are balancing the weight, which is mg of the needle, cylindrical needle. I hope that makes sense. So that's the reason why SL plus SL will be equal to mg. Therefore, m will be equal to 2SL divided by g. 2SL divided by g. I hope this is now understood. Okay, amazing, amazing. Perfecto. So we have over here 2SL by G. Vicky, you should watch the video which I uploaded last week. It's all mentioned over there. Okay, it's 4 minutes 44 seconds. Just watch that video. Very good. So 2SL by G, that's the answer. Moving on to the next question coming up on your screen. There is a wooden stick 2 meters long. It's floating on the surface of water. The surface tension of water is 0.07 Newton per meter. By putting soap solution on one side of the stick, the surface tension reduces to this much. What is the net force on the stick? Okay, let's try and draw the diagram, so that will be better. Okay, so we have the stick right over here. Okay, so this is the stick, let's say. Okay, this stick is somewhere like this. Okay, and the length is obviously L. This is our stick. Okay, so on one side you have water. Okay, so on one side you definitely have water. So this is your water surface. Okay, this is your water surface, something like this. Okay, so the one side you have water. But on the other side, because you have dipped it in some, or poured some soap solution, the surface tension changes. So I'll show it by another color just to make you realize there are two liquids on either side of the stick. So you can see there are two different kinds of liquid on both the sides of the stick. This is the surface of the fluid. I hope you can visualize that. Now what will water try to do and what will the soapy solution try to do. Visualize this. The soap solution will apply a force this way on the length of the liquid, correct? Will apply a force this way. Whereas the water surface will try to contract its surface this way by pulling it this side, correct? So there is a tug of war. Do you see that there is a tug of war between water and soap? Can you see that, my warriors? Can you see that there is a tug of war? So the question is, what is the net force? So the net force will be the bigger force minus the smaller force. As simple as that. So the net force will be the bigger force minus the smaller force. So force 1 minus force 2. Who will be bigger? Water surface tension is more, soap surface tension is less. So it will be the force by water minus force by the soap. What will be the force by the water surface? It will be S into L. So S, but S is different, into L minus force of the soap will be S different into L. So basically L is common and you just have S1 minus S2. So what is the length value? The length is 2. What is surface tension? 0.07 and 0.06. So bigger number minus the smaller number, and there we go. It's just going to be 2 into 0.01, which is 0.02 Newton. And I think we have it in option number D. Think carefully and try to understand, why did we not multiply this entire thing with 2? Why did we not multiply it with 2? Think about it. Why was 2 not there? Not because it's not there in the option, but why the 2 number or the 2 factor was not there? Understand, this is the surface of a fluid. There is no surface below. Try to understand this. Okay, imagine this was the liquid surface, somewhat like that. Below it, it's complete liquid. So there is only one surface on the top. There is no surface below it because it's completely full with liquid. It's not exposed. When I mean a surface, it means it should be exposed. I hope that makes sense. So if I have a container and there is water filled over here, okay, this water is filled over here, understand, at this point you have only one surface. How many surfaces you have? Exactly one surface which is exposed to the air. But the moment you have a film, then you have 1 and 2 surfaces. Here in this problem, the situation was somewhat like this. The needle, that stick was on the water surface, not on a film. If it was a film, then it will be 2. But the film is not there, it's just a liquid surface, there is water below. Hence, that into 2 is not there. Very good. That's what you need to understand. Now we're going to come up with a very brilliant question. Get ready. It's going to blow your mind. Okay, so beautiful question. Pay attention. Something like mains plus advanced or just advanced. There is a horizontal film of soap solution. Okay, horizontal. On it, you have placed a thread in the form of a loop. The film is pierced inside the loop and the thread becomes a circular loop of radius r. If the surface tension is S, what is the tension in the thread? Interesting. Let's try to understand this. Okay, Divya, we are going to do PYQs in the sprint series. If you notice, in sprint, there are lots of questions which are based on PYQs plus my own question bank plus Vedantu's question bank. After sprint, we are going to do PYQ. So understand the order of events. Just by doing PYQ immediately, you might lose confidence. So that's the reason why I'm trying to do all kinds of concepts first, and then you will be seeing lots of PYQ exclusive. Right now, we have PYQs even in these sessions and even in sprint sessions. But it's not complete PYQ, because if it is complete PYQ, then it spoils the entire essence of those sessions. So that's why we're going to have exclusive PYQ series after the sprint. Okay, hold on for that. Now, imagine this. This is my, film, and you have a loop of thread like this. Okay, so what is this? This is a loop of thread. Now, obviously, there is film formed over here like this. This is the film. The loop of thread is over here. If somebody punctures this part, what will happen? There will be no film over there. So you just have that thread like this, correct? And there is film only from outside. And what is the property of any liquid? What's the property of any liquid? The property of a liquid is always to contract, reduce its area. So there will be force from here, from here, from here, from here, from here, like this. Every side there will be force, correct? It will try to minimize the surface. Look at this, the moment it contracts, this yellow part will shrink. The outer periphery will shrink. Do you guys understand that? It will not become a dot. A lot of people think, sir, this thread will become small like this and it will contract. No, in fact, the thread will expand because the liquid is not there inside. The liquid is there outside. So the outside area should decrease. Inside area should increase. Does it make sense? Because only when the inner surface area will increase will this area decrease and there will be minimum area over here. So this outer periphery will have minimum area. Understood till this point? So eventually what you're going to have is this loop which is going to be circular in nature. It's going to be circular in nature. So the question is, what's the tension in the thread? So let's just imagine, let's just imagine that this is the thread. Okay, this is the thread. This is of radius r and it has expanded. There is nothing inside. There is only liquid outside of this. Okay, there is liquid only outside of this. It has expanded. There will be tension everywhere. Correct? There will be tension everywhere. So the whole idea of these circular problems is to take a small element of the thread, draw the free body diagram, and then solve it to find surface tension. Whenever you see such kind of problems of circular motion, where everywhere the tension in the thread is same, always choose an element. So when you choose an element, draw the free body diagram. And once you draw the free body diagram, write the Newton's laws equations, and then you will get your answer, whatever is not known. So just follow these steps. So let's choose an element first. Let me choose a small element which is like almost like a arc which is going to turn into a straight line. So this is my element, and probably I'll just show the element somewhat like this. This is highly exaggerated, but understand that element is actually this much. Okay, it's hardly like this, but I have exaggerated and shown it to you over here. Okay, let me also draw an angle bisector because I'm going to need it eventually. Okay, you will understand why. Let's say this small angle over here, the small angle over here is d theta. It's d theta. Then also the small angle over here will also be d theta. Everybody agrees it's an angle bisector, d theta and d theta. I have assumed that. The length of the arc, the length of that arc, how much will it be? Length of the arc is r into angle subtended. So r is the radius, the angle subtended is d theta plus d theta, so it is 2 times of d theta. That's the length of the arc. What are the forces acting on that arc? Think carefully. One force is basically the force of tension. The force of tension will always act tangentially. So this is the force of tension within the thread. Every point on the thread will experience tension. This point will also experience tension. Tension will act tangentially. So the tension is always going to be tangential to the thread. So tension here, and there will be obviously tension this way. I can also see that the tension force can be split into 2 components, and I'll see how. Like this, if I draw a horizontal line and if I draw a vertical line over here, a horizontal line and a vertical line over here, look at this. The tension force is easily split into 2 components. Can you see that? Which components are cancelling? Quickly answer in the chat box. Is it the vertical components which are cancelling, or is it the horizontal components which are cancelling? Quickly answer in the chat box. What do you guys think? Because only when you think that way, you will be able to understand what to do next. Is it the horizontal components which are cancelling, or is it the vertical components? Yep. All the needed topics, yes, Vignesh, they are covered in Nurture series. Yep. And there are also a lot of advanced classes for advanced oriented problems or sessions as well. Horizontal are cancelling, not vertical. Be careful, it's not vertical. In fact, verticals are adding. Look at this, vertical. there are two components like this, they will add, but one component here, they will cancel each other. So opposite components will cancel each other. I hope you can see that. So vertical components will add, horizontal in opposite will cancel. I hope that makes sense. Fair enough. How much are those components? That's also easy. If this is d theta, do you see this is d theta, this is also d theta, d theta, d theta, two parallel lines. If you have two parallel lines and like this, correct, this angle is always equal to this angle. So same thing is happening over here. So this is d theta, this is d theta. If this is d theta, even this is d theta. If this is d theta, this is 90 minus d theta. This is also 90 minus d theta. Correct? Because this angle totally should be 90 degrees. Correct? Do you see that? This angle totally should be 90 degrees. So this is d theta, this is 90 minus d theta. And that will be complementary of that. So again, this angle as well as this angle, both angles will be d theta. This will be also d theta. So which components are adding? So I'll just mention that over here. So t cos d theta basically cancels, whereas t sin d theta basically adds up, adds together this way, downwards. Do you see that? T sine components, the sine components will add up. Fair enough, everyone. T sine d theta components are adding downwards. The question is, who is balancing them? Because I know this thread is at rest. It's not moving, it's at rest. So there must be some force to cancel it. And that's obvious that the liquid is there from outside. Remember, this thread was like this. There was force of surface tension everywhere trying to pull the thread. So yes, there is surface tension force which is acting from outside. So definitely you will also have the force of surface tension somewhere like this. Okay, so these forces are there, but I'm not showing all the forces. The net force will be vertical. So this is the force of surface tension. This is the force of surface tension. Now, once you understand all of that, since the net force on that arc of the thread should be 0, the net force on the arc of the thread should be 0, is it not right for me to say the force by the surface tension, the force by surface tension should be exactly equal to the net force by tension force alone, tension in the thread, think about it, the tension in the thread, which force of tension? T sine theta components. T sine theta will cancel out this force. Both are equal and opposite. Understood? Got this, my warriors? Is this concept clear till here? So what and all we have done? There was a thread, it was kept in a film. The film inside was punctured, so it expanded. The force due to surface tension pulled it from outside. There was immediately a tension created. Tension is same everywhere. So to analyze that, we took a part of the arc, or that we took a part of the thread which is an arc. That arc is very small, so it subtends an angle of d theta, totally 2 d theta. So tensions are here, the horizontal components cancel, vertical components which are t sine d theta by geometry add, they are balanced by that pull due to the surface tension. As simple as that. Now, how much is this force by surface tension? It will be S into the length of that arc. Correct? It will be S into the length of the arc. And this will be 2 times, or rather think of it this way. It will be T sine d theta plus T sine d theta. Because I just told you, they both add up together. They just add up, right? So T sine d theta plus T sine d theta will be 2T sine d theta. But wait a minute, sine of a very small angle is the angle itself. Remember that, sine of very small angle is the angle itself. So it will be 2t d theta. And the length of the arc, I think I just got it over here, r2 d theta. So it will be s into r into 2, okay, and into d theta. But there is one more catch over here. in case you have missed it. The catch over here is that S into L is not the only force. It will be 2 times of that. Yes. Why this 2 has come? Because there are 2 surfaces. There are 2 surfaces. Which surface? One in front of you, one is behind. Visualize it. It's a film. So the top surface will, apply one force, and the one which is behind will also apply a force. See if this is clear. Yes, Karthikeya, the crash course has just started this Monday, and the link is there in the description box, bacha, for 2022. Just check it out. It is there. Use the link, use my coupon code, everything will be sorted. So basically, if you look at the film, one surface tension force from here and one is there from behind. So 2. So that 2 factor is very important. If you don't bisect the question, bisect the angle, still you will get the same answer. Wherever you have put d theta, you will have d theta by 2, d theta by 2. Everywhere you will get by 2 by 2. That by 2 by 2 will cancel. So it is not going to matter what you take as d theta or d theta by 2. That doesn't matter. It eventually cancels out. So eventually what is all is going to get cancelled? D theta, 2 and this 2. So therefore, what are you going to see? T is equal to 2 times of SR. So that's our final answer. 2 SR. That's the answer. Got it, my warriors? 2 SR. Is it there? Option D. That's the correct answer. How many of you loved this question? Wasn't it the most fabulous question of surface tension combined with mechanics? Isn't it? So beautiful question. And this 2 is very, very important because it's a film. It's mentioned. It's a film. The moment you read the word film, you should immediately visualize that there will be 2 surfaces. So that 2 automatically should click in your head. Got it? So that 2 should automatically click in your head. So the answer is D. Perfect. And remember, the entire PDF and all the problems as well as the homework solutions of all the classes are always uploaded in our new Telegram channel group. Make sure you join it, okay? Because you'll get all the problems. You can download the PDF. It's very important. And yes, all those of you are looking for 11th or the 12th crash courses, it's all there in the description box. There are links. Make sure you check out the link for joining the Pro Sub. Use the coupon code SHHPRO to get the 10% off. And make sure you join ASAP because the portions have already started and you do not want to miss out on those portions. And yes, there are limited entries because as soon as those entries get over for that batch, then the opening for the new batch starts, which might take some more time. So make sure you join it ASAP. All right. So let's move on to the next part, and that is surface tension. RS, is JEE still possible? Yes. Let me give you an honest answer. Definitely. Let me tell you, there are many students of mine who started very late preparation. In fact, last year also, there were many students who just started towards the end. They had very basic idea. Still, they managed to get into NIT, but by lot of hard work. And yes, it is possible. You need to have that willingness to put in that hard work. You need to have that passion. And you need to sacrifice a lot because obviously you will be competing with students who are preparing for 2 years. But yes, it is possible. I have seen it last year also. And I know it is possible because I have gone through all the process. I know what it takes. And even if you have missed out on a couple of things, it's fine. Sometimes things happen, things go wrong, but it's better late than never. But if you delay it more, then it becomes more difficult. Start today, start now. Okay. Now, let's talk about surface energy. I just told you that, all the molecules on the liquid surface, they have more energy, they are more unhappy as compared to the molecules on or in the bulk. So, we just talked about the surface molecules. So, the molecules on the surface, basically they are unhappy. And the molecules in the bulk is basically happy. Also, it means if you have no surface, then there are no unhappy molecules. If there are no unhappy molecules, that's the best possible scenario. That's hypothetical, but just important. So, molecules on the surface, because they are unhappy, they have energy, more energy with respect to the bulk, with respect to that bulk, as compared to this. If you compare their happiness or sadness, that is called as the surface energy or the surface potential energy. So that extra energy which the molecules on the surface have, because they are not satisfied, they have not made enough bonds, that extra energy as compared to the bulk, the more happier molecules, they are called as surface potential energy. So when there is no surface, then I can easily say that the surface potential energy will be 0. So what will the surface potential energy be? It will be just 0, as simple as that. Now, we can calculate how much surface energy is there, for any given liquid surface, and it's very, very easy. So just imagine this way, okay? There is a C-shaped wireframe, okay? It's a C-shaped wireframe. There is a rod, and this is the force due to surface tension, okay? And it has some area, of course. Let's say the length of the rod is L. Let's say this width is X, okay? Let's say this width is X. And say, for example, this surface tension, when it goes from, or basically when you take this rod from here to here, say for example, you move this rod from here to here by an amount of dx, do you see that just because you have moved the rod over here, you have created a new area? You have created a new area over here. So you have done some work in this process. If I ask you, how much area have you created? How much area have you created by moving the rod against the will, against the surface tension force, by applying some external force? What will your answer be? What will your answer be? That extra surface area. How much surface area A have you created? Answer this question quickly, my warriors. This is L, this is dx. You have moved it by dx. How much area have you created? What is the height? Length, L. What is the width? It is dx. So L into dx, L dx, but there are two surfaces because it's a film. So that's why it will be 2 times of L dx. Why this 2 has come? Because there are two surfaces. Two surfaces. One on the front, one on the back. So this A stands for the total surface area. Total surface area. Be careful. Fair enough. Now, by simple logic, by work power energy principles, I can say that the work done by the external force has gone in increasing the surface potential energy. Because I have to do some work, I have to pull it to increase the surface against its will. It doesn't want to. So I have increased its surface potential energy by creating the surface by doing some work externally. How much is that work done by the external force? Is that external force into dx. Work is force dx. And the surface potential energy increase will be du. What is that force equal to? Obviously that force will just balance the inside force, surface tension force. So it should be nothing but 2 times of SL into dx will be equal to du. Now 2L dx, I have mentioned it. It is the surface area which has been created, right? It's the new surface area which has been created. Since it's a small area, technically I should not write it as A. I should write it as dA. Because this is the new extra surface area. That's why the dA word has come, not A. Technically, dA will be the right word. So can I say this L into dx into 2 is nothing but S into dA? S into dA. That dA is the extra total surface area which has been created on both the sides. This is equal to du. Perfect. Now just add the integral symbol on both the sides. If you integrate on both sides, what will be the limits? When there is no surface, that means area is 0, the surface potential energy is 0. When the surface area is A, the potential energy is U. Therefore, the final answer will be over here U minus 0 and here S into A minus 0. Just rearranging it, I'll get U is equal to SA. So USA, keep this in mind. United States of America. USA. What is U? Energy, surface potential. S, surface tension. A, surface area. That's it. That's what you need to remember. Why 2SL, Varun? I just mentioned because there are two surfaces, right? So again, the same concept right over here. There are two surfaces, one on the top, one at the back. Okay, so that's why there are two surfaces, one in the front, one in the back. So one this side, one this side. See this. This is the surface at the front. This is the surface at the front. This is the surface at the front. These are all bulk. This is the surface at the back. So many layers are there. All these things are basically the bulk molecules, bulk layers. So there will be force from this side. Okay, there will be force from this side, and there will be force from this side also. So that's why 2SL, SL, SL, 2SL. Make sense, my warriors, how it works? USA, keep this in mind. So S is, surface tension can be also written down as surface energy by area. This is another way of remembering it, but it's the same thing if you notice. Okay, S will be nothing but U by A, or basically U is equal to SA. It's one and the same thing. Now, if you change the area, energy will change. So if you have any changes, then you can use this formula. Del U is equal to S delta A. So if you have any kind of changes happening in the area, delta U is S into delta A. Use this formula. Fair enough. Let's do some questions coming up on your screen now. So let's blow some bubbles and solve the questions on this. It's a beautiful concept. Let's do this all together. All geared up, my warriors? Yep. How's the Josh? Ready to do some questions on bubbles? All right. Now, don't you think we need to do some work to blow the bubble? What do you guys say? Don't you think we need to do some work to blow the bubbles? Because you are increasing the size. When you increase the size, you change the area. And when you change the area, you are increasing the surface energy. The moment you increase the surface energy, it has to come from within you, from your energy. And that's what we need to do. Here it is. The work done in blowing a bubble of radius 2r from r using the same solution having surface tension S is, so you have a bubble which is initially of radius r. So this is your initial diagram. This is having radius r. This is initial. So what you do is you blow it and make it really big of radius 2r. This is final. So the question over here is, in this process, how much work you need to do? That's the question. Come on, this is very interesting. The answers are going to be in S, pi, r, etc. Maybe some constants as well. I know for a fact that many of you are going to get the wrong answer. I know this. But let's see how many of you can do this and give me the correct answer. Yep. There are no options out here, so let's see how many of you can put up the final answer in the chat box. Come on, think carefully. Okay, so what do we need to do? Work, right? What is work? Work is change in the potential energy. So in order to calculate how much work is needed, you need how much is the change in surface potential energy. That means we need final potential energy minus initial potential energy. Final minus initial. So let's talk about it. What is the initial potential energy? The initial potential energy, USA, use that formula. Initial potential energy will be S into initial area, which is S into, what is the surface area? It is 4 pi r square. The surface area is 4 pi r square. Correct? Now, same thing for final. What will be the final potential energy be? It will be U is equal to S into A final. That is S into 4 pi 2r whole square. Correct? So I'll just put it right over here. S into 4 pi 2r, because that's the new radius, surface area of a sphere. Don't you think we are missing something? Don't you think we are missing something? What is it that we are missing? Can somebody point it out? We have done some mistake out here. Come on, my warriors. Think about it carefully. What do you think we have missed? It's a bubble. Visualize a bubble. I just gave you I just showed you the simulation of a bubble. How does it look like? we have missed something. A bubble, believe me, there is air inside and there is air outside. And this bubble is nothing but a film, right? It's a film. Correcto, Avantika. Very good, Dakshin. And there is one surface here and there is one surface here. So there are two surfaces, in and out. This is outside surface and there is inside surface. Don't you see that? It's a thin film. And both the surface areas are roughly the same because the thickness is negligible. 4 pi r square, 4 pi r square. Be it inner surface or be it outer surface, hardly any change in the radius. So, don't you think I should multiply this with 2 over here and also multiply this with 2 over here? Isn't that right? So, basically what did I get? This is nothing but 8s pi r square. And what is this? This is 4 2s are 8. 2 square is 4. 8 into 4, that's going to be 32. So 32 s pi r square. So final is 32 s pi r square and initial will be 8 s pi r square. So hence the final answer 32 minus 8, that's 24. So 24 s pi r square. That's the work done. That's the answer. Done, done, are done. Many people miss that 2 and because they forget to multiply it by 2 on both sides, so the answer comes out to be 12 s pi r square, which is wrong. So the correct answer is 24 s pi r square and not 12 s pi r square. Okay, so that's the catch many students may miss out. All right, perfecto. Let's move ahead. So I'm pretty sure you have enjoyed this question. Now that we have spoken about bubbles, let's move to drops. Let's talk about some questions on drops. It's going to be amazing. Okay, look at this drop, and now I'm pretty sure looking at this drop, you are getting that feeling of surface tension. It's as if that liquid surface does not want to bloat, does not want to become big because it wants to contract. It's trying its best to remain intact. But as more and more water falls inside the drop and it accumulates, the weight of the drop becomes very big. After a point, the drop just says, sorry boss, I cannot hold you because the drop's surface tension is much smaller than the weight of the drop itself. So when the drop's weight exceeds the forces due to the surface tension, it's going to break off and it's going to fall down. That's what happens. That's the reason why it stays till some time. At the moment the force exceeds, it breaks off. Here we have a question, something similar to a drop. There are two drops and they merge with each other and it forms a bigger drop. In this process, what do you think will happen? Is energy liberated? Is energy absorbed? Nothing happens? Or is some mass converted into energy? Interesting question. Let's see how many of you can visualize this and get the final answer. Come on, my warriors, figure this out. So we have two drops. These are the two drops. This is what is there initially. Finally, what happens is the drops merge and they become a bigger drop. So what do you think will happen? Will the energy be liberated? Will it be absorbed? Will nothing happen? Or it depends, like something like mass will be converted into energy? What do you think is the correct answer? Okay, I'll give you a hint. Think of the reverse, it's easier. Because whatever will happen when you break the drops, exact reverse will happen when you accumulate the drops and convert it into a bigger drop. Tanuja saying B. Aniket, there is no option like H, bacha. Okay, chalo, let's think about it. What do you think will happen when you actually break a drop into two? Just think what will happen then, just reverse it. That's all. Anjali saying B, Avantika saying A. Well, here is the logic. When you have a drop and you break it, so let's say this is one part, this is another part, correct? When you break it, now don't you see you get additional surfaces? Don't you see you got some additional surface? New surface which was already hidden. This was actually hidden surface. Now you got additional surfaces. Yes, the drops will realign themselves into two drops, but you had that new surfaces being formed, correct? So don't you see, when you have separate drops, you have more area. So this has more area. And what does more area mean? More area means more the potential energy, the surface potential energy is higher. The surface potential energy is higher. But when you have it as a one complete drop, the surfaces get hidden. So you have lesser area. So when you have lesser area, the potential energy is less. So from this process to this process, what has happened? The area has decreased, the energy has decreased. So if energy has decreased, it has been released. It has been liberated. Correct? The answer should be A. Correcto. Perfecto. So that's the logic behind it. So the surface area decreased, energy decreased. So if the energy has decreased, it has liberated. So the potential energy was more, finally the energy was less. So some amount of energy was liberated. This is according to the law of energy conservation. More energy is less energy plus some remaining energy. That's it. As simple as that. Hi Sakshi, welcome. Good evening, Bachalo. That's option A. Moving on to the next question coming up on your screen. There are 8,000 identical small drops. They combine to form a big drop. What do you think is the ratio of the final energy to the initial energy of all the drops? Think carefully. When all the drops were separate, they would definitely have large area, all surfaces exposed. When they combine to form one single drop, you'll have very little surface because it's one single drop. So the new energy will be less, or the final energy will be less. The original energy will be lot. So that's why the ratios are lesser than 1. 1 is to 10, 1 is to 15, 1 is to 20, 1 is to 25. Let's see how to do this question. First of all, there are 8,000 small teeny mini drops, correct? So we have these drops, let's say each of radius r, and we have 8,000 drops. Eventually what happens is that they convert into one big drop, let's say of radius capital R. So this is your final drop. So let's try to analyze what was the energy initially, what was the energy afterwards. But before doing that, I have a simple logic, but okay, let's do this. Initial energy, okay, 8,000 identical drops, they combine. So initial energy will be S into area initial, but there are 8,000 of them. Each drop will have its own area. So it will be S into 4 pi small r square into 8,000. So this is my initial energy. When they combine, there is one thing which remains constant. That is not their area, it's their volume. Because mass has to be conserved, density is same. So volume also has to be conserved. So whatever is the volume of all their drops, when you add that, it's like adding some water, then adding some water, adding some water. The total water will be the sum of all the volumes, correct? That's all. So here, what I can say is that the volume is conserved. And if the volume is conserved, my dear warriors, think what should happen. Initial volume will be 4 by 3 pi r cube, but there are 8,000 such drops, will be equal to final volume, which is 4 by 3 pi capital R cube. Volume of each drop into 8,000 such drops is equal to final volume. Lot of things are going to get cancelled, like 4 by 3 pi, 4 by 3 pi. And 8,000 is 20 cube, 2 cube is 8, 10 cube is 1,000. So this will be R into 20 whole cube is capital R cube. So can I say 20R is equal to capital R? Okay, I think I'm going to need this. 20R is equal to R, maybe later on. Finally, what was the final energy? Just one surface of the final drop, S into 4 pi capital R square. As per the question, you have to find the ratio. And what is the ratio? The ratio is final. Okay, so final means S into 4 pi R square divided by initial. The ratio of the final to the initial. So initial will come below. So the initial energy will be this much. So S into 4 pi small r square into 8000. What and all have got cancelled? S, 4 pi, 4 pi. Now capital R is 20R cube. Capital R is 20R cube. So square, my bad. So capital R is 20R. So I have to square it over here. So 20 square into R square. That's what I'm going to get in the numerator. And in the denominator, I will have small r square into 8000. You can obviously see small r square cancels. 20 square is nothing but 400, 0, 0, 0, 0. This 4 will go with this 20 times. Correct. So the answer should be basically 1 by 20. And I think it is option C. Just check this out. Isn't it? Perfecto, Bharat. D. Yes, it is option C. Very good, Sushila. Very good, Chandan. Very good, Avantika. I just saw all of you and all of you have answered correctly. Perfect. I'm very happy that you have got it correctly, guys. Okay. So it's all about knowing what to multiply where the volumes are getting added. That's what we have used. Second thing, difference of the areas are leading to different potential energies, USA, and just making sure this 8000 is there. If you miss this 8000, then you'll get a completely wrong answer, because there are, so the question says the final surface to the initial surface. So initial surface of all the drops. Of all the drops, that's why that 8000 is there. Got it? Cool. Moving on to the next one. Oh yes, the chapter is over. I mean, this part is over. Now what are we going to do next time? Let me tell you that. Next time we are going to do pressure in drops and bubbles. That's what we are going to do. Pressure in bubbles and drops, and pressure difference across curved surfaces. So we are going to do pressure difference across curved surfaces, and yes, we are also going to do capillarity. That's what we are going to do, and also angle of contact. That's what we are going to do in the next few classes. Now this is your first homework question. Make sure you write the answers in the comment section below. And this is your second homework question. Make sure you drop the answers in the comment section below. And these are our students who have marked the correct answers, or at least attempted the questions last time. For viscosity, you can see that right over here. Very good, Ishpreet. And then we have Harita. Very good. I'm all going to give you hearts. Ishpreet has enjoyed the session. I'm so happy to look at these hearts and these smileys. Very good, Dakshin. Thank you, Sushila. Very good, Navina. Very good, Saja. Very good. Yes, all the topics are covered, Vignesh. Don't worry about it. Thank you, Subiksha. Thank you so much, Subiksha. And I cannot read this name, but yeah, I'm so glad you wrote that. And Saudamini, is this course for JEE Advanced? Yes. And any other course for JEE Advanced? I'm just going to show that to you right over here. So right now, oh, by the way, the solutions will be uploaded on our Telegram channel. Now, if you want the courses for JEE Mains and Advanced, so obviously you want JEE, okay, Mains plus Advanced. So it's all there for 11th standard students as well as 12th standard students. So how it's going to work? Let me explain that to you. See, for 11th standard students, right? So when you join now, okay, till your 11th standard end, that means around February, March, so 11th end. So your 11th syllabus is going to be over. So that's till February or March, let's say. You will also have lot of, problem solving sessions. You will have micro courses. You will also get KVPY material. Okay, all of this is a part for 11th standard students, and once 11th standard ends, you automatically auto-enroll into the 12th standard, and your course will continue for the 12th standard till maybe, let's say, October or December. Okay, I'm just giving a rough timeline. It depends which batch you choose. And then after that, your revision will start, your mock tests will start, etc. And your final preparation for JEE and other exams, JEE, CET, boards, etc. All those things are taken care of. And if you join right now for the 12th standard, So you are going to get enrolled into the crash course. It will have mock tests, you will get assignments, everything. You will have recordings. Here also you get assignments and test series, everything. So that's the flow. So this is still your final preparation or final JEE exam. Now, if you are interested in joining this, I'll tell you what's the course fee. But yes, let me tell you again that the courses are actually in English. Yep, the courses are in English, so you don't have to worry or struggle around with the language. You obviously get your tests and assignments. For 11th standard per month, the price is just 1,350 rupees for the light package. The light package will give you everything what I told you. But many students also go for the classic version. So what's the advantage in classic version? Some of you might know it. Well, in classic version, what you get is doubt solving on the mobile app. That's what you get. So that is after the class. And in the plus version, what you get is this extra feature, which is the personal mentorship. So I would suggest you to try out at least light or classic. Take it out for 1 month because it's hardly anything. 1,800 rupees, 1,350 rupees. So that's not much. And if you're wondering where would you get this from, it's very simple. Now, if you're watching this video, all you need to do is just go into the description box down over here, and you will see right over here, yep, register for JEE crash course. That's for 12th standard, and for 2 years, this is for you guys, 11th standard students. This includes your 11th and 12th standard courses, assignments, doubt solving, everything. So you can see this is the total price if you pay it upfront, and you can also avail EMI options. That's up to you. And you can see that when you use my coupon code, you save additional 10%, which is very important. And you can click on try for 15 days, or you can click for buy complete course, pay via EMI, whatever you want to. Those are all the options that are there. You notice these prices are very low as compared to any other institute. You go to any offline institute, they will charge you minimum 2 lakh rupees with half the things not being there, whatever we are offering. So it's one place where you get everything right over here, and the best teachers of the country are over here, let me assure you. Okay, so I'm hoping to see all of you, because even my courses are going to be available when you join the pro courses. Let me tell you that. Okay, thank you so much for joining in. Thank you, Sujal. All right, Bharatraj, put up the answers in the comment section after the video ends. All right, so bye bye, take care, have a great time, and yes, I'll hope to see you on my Instagram. And you can definitely chat with me out there if you face any difficulties. And yep, do not forget to smash the like as well as the subscribe button. It was wonderful seeing all of you out here. See you in the next class tomorrow, and have a great time. Study well, keep working hard, and obviously stay safe. This was Shreyas here, your capto for this channel. Hasta la vista.